Welcome to all. In the previous lecture, we have discussed about binary trees. A binary tree has every node has at most two children. Maximum number of child nodes for every node in a binary tree is 2. We have seen several operations which can be performed on a binary tree, and we have seen how traversals, that in order, pre-order and post-order, can be done on a binary tree. Now we will be discussing about a new type of binary tree, another type of binary tree, that is called binary search tree. In a binary search tree, we can call it as a sorted binary tree. It is a binary tree. It can be empty, or each node in the tree has an identifier such that all identifier in the left subtree of T are less than the identifier in the root node T. So consider an example. In this tree, it is a binary tree. Every node has at most two children, and the root node is having a value 30. If you are noticing, you can find that each node has a value. This value is called an identifier. It can also be called as a key. So, in each node, we have an identifier. For example, if we are storing data of students in a database, every student has a roll number starting from 1 to 64. Then the number 1 to 64, that is the roll number. It can be used as a key, a unique number that can be used to identify each student. Similarly, in a binary search tree, every node has an identifier. That identifier will uniquely identify each node in the binary search tree. So here the root node is having the ID 30. If you look at this example, it has a left subtree. It has a left subtree, that is a tree which is rooted at 15, then its left child is 7, right child is 22, then 17 and 27. That is the left subtree of the root node. And the right subtree is having nodes 60, 45 and 75. This is called the right subtree of the root node 30. So if we consider the root node, it is 30, and all the nodes in the left subtree is having a value lesser than the root node. Listen, 15, it is lesser than 30. 7, 22, 17, 27, all these values are lesser than the root node. So for any node in a binary search tree, every node on its left subtree will have a lesser value for the identifier, and every node in its right subtree will have higher value than that of the original node or the root node. In this case, the root node is 30. The right subtree is having values 60, 45 and 75. Each of these values is greater than 30. So in a binary search tree, data is arranged in a particular way. The particular arrangement is that if you consider one node, then every node in its left subtree will have a value which is lesser than the node, and every node on its right subtree will have a value greater than that of the node. Consider this node 15. So it is the we can consider it as a tree starting from 15 or rooted at 15. If you consider that node, Its left subtree is having a node 7 and its right subtree is having 3 nodes 22, 17 and 27. Then for this node, its left subtree is having a value lesser than that node and all nodes in the right subtree is having a value greater than that node. That is the condition in a binary search tree. It is a sorted kind of tree. There are a lot of applications or there are a lot of benefits if you are ordering values like this. So as we always mention in data structures, it is all about arranging data in a particular manner. Why? Because we need to use them in an efficient way. We have to perform several operations in the most efficient way. So in which order I have to arrange my data so that I can perform the operation in the most efficient way? That is the question. To tackle that, one method is storing the data in terms of a binary search tree. So, um, so this is one example. Then, all the identifier in the left subtree of the tree of the root node T are less than the identifier in the root node T. Then, all identifiers in the right subtree of tree are greater than that of the identifier in the root node T. Then the left and right subtree of T are also binary search trees. So it is a recursive thing. Here we have the root node 30. Its left subtree is having all nodes with values less than 30. Its right subtree is having all values which are greater than 30. And look at the next node. This is level 1. This is level 2. Look at level 2. There we have a node 60. This is a recursive procedure because if you take node 60, its left subtree is having a lesser value than 60. Its right subtree is having value greater than 60. Similarly, consider node 22. There, its left subtree is having a value lesser than 22. It is 17. Similarly, its right subtree is having a value greater than 22. This is the condition for a binary search tree. For any node, its left subtree should have values lesser than the node. Its right subtree will have values greater than the particular node. That is the condition of arranging data in a binary search tree. The advantage of arranging data in this way is the complexity of search operation in binary search tree is big of log n to the base 2. We will discuss about it in detail. So in computer science, a binary search tree abbreviated as BST. So it is also called an ordered or sorted binary tree. It is a rooted binary tree data structure. Its internal nodes each store a key value greater than all the keys in the node's left subtree and less than those in the right subtree. So, this is the example. For any node in the tree, its left subtree will have lesser values. Its right subtree will have greater values for any node in this tree.